Good morning, everyone. Today is Monday, April 12th, and we're going to be working on Unit 6, page 11. Last week and even a couple weeks before break, we were working on solving two-step equations. And if you remember from our definition of an equation, it is two expressions that are set equal to each other. So we have that equal sign. Today, we're going to be working on something similar, but they're called inequalities because we'll be using four different symbols instead of that equal sign. Before we get into all of that, I want you guys to pause the video here and try the review question. And then take a look at the preview question, see if you can kind of think about what would happen if the two expressions weren't equal to each other. And there's also a little scavenger hunt activity to finish off our day. So go ahead and pause and then come back. All right. Hopefully you paused your video and got to look at both of these questions. My review question is just solving a two-step equation. Like I said, we've done that for quite a few weeks now. So we can take our expression from the left side, x over 5 plus 3. Set it equal to our expression on the right side. So I just copied the equation from there. We can draw a hanger diagram or a tape diagram if needed. Or we can just solve this algebraically. I'll give myself some more space there. Draw my line down the equal sign. Subtract 3 on both sides because we're trying to get x all by itself. Those will reduce to 0 because a positive 3 minus 3 equals 0. We still have our x over 5, but that's now equal to a new number. 12 minus 3 gives me 9. And our very last step is to try and undo this division. Right now it says x divided by 5. We've got to do the opposite again to try and get that x by itself. Oops. I'm multiplying, not dividing. Anytime you divide and multiply by the same number, it actually reduces to 1. So we have 1x left on the left side, and we have 9 times 5, which gives me a 45 on the right side. Okay. For our preview question, like I said, just kind of think about what you think would happen if this symbol wasn't an equal sign. Could we still solve for a missing variable using these same kind of rules, maybe a hanger diagram, maybe a tape diagram? Let's figure it out. And while we're doing that, we have to kind of take a look at what those 4 new inequality symbols will be. So this little scavenger hunt activity just says, look around this page. Let's try to find those 4 new symbols that we're going to be using. And if you just scroll down to exercise 1, you kind of see all 4 of them. We have this one, which kind of says the number on the left is greater than whatever number is going to be on the right. Okay, so that's greater than. I'm going to type that in at the bottom when I find all 4. We have the opposite direction, less than. And then we have these with the little line underneath them. So that's going to be greater than or equal to. It's kind of a combination of this and a regular equal sign. And we could also have less than or equal to. Again, kind of a combination of the less than symbol with an equal sign. I'm just going to fix this one up real quick. And I will kind of type in those names underneath here just so we have them. Greater than. Oops, pressed my tab there. Didn't quite want to work. We have less than. Greater than. Or equal to. and. So that's for this symbol here. And then the very last one is less than or equal to. Okay. And let's take a look at what those will mean. Oh no, some things got messed up with my whole page here. Let me fix that real quickly. Make sure the rest of my page didn't get all messed up there. Okay, I fixed it. So I'm not going to take those in again, but hopefully we have them. You can go back to that section in this video if you need to get those, but sorry about that. So now that we know what those four symbols are, we can go down to our exercise 1 in our notes and state whether each of the following inequalities would be true or false. If you remember from when we did this same thing with equations, you can say that something is true if the two sides are actually equal, okay? And that's the same thing with inequalities. If that inequality actually makes sense with the two numbers that are on both sides, then it's true. If it doesn't make sense, if it's not true, we say it's false. And so this one, we said, says 8, then it has our greater than symbol, and then a 4. So is 8 greater than 4? Yes, we can say that is true, T for true. If I go over here to B, now we have our greater than or equal to. So it's saying that 9 has to be greater than, or it could be the same number as 12, okay? We obviously know they're not the same number, so we can check that greater than part. Is 9 greater than 12? No, that's false. If I go over to C, now we have less than. 10 is less than 7. And that is also false. That's incorrect because 10 is supposed to be greater than 7. We have our question D here. 14 is less than or equal to 15. We can check that equal to part, but we already know those are two different numbers, so that part's not exactly true. But the less than piece here, 14 less than 15, is true. Okay, 14 is smaller than that number, 15. So even though that equal to part wasn't true, the other side of it was, where I said it's kind of a combination symbol. So we can say the whole thing is true. Same thing for E here. We have this greater than, we have a less than symbol. 3 is less than 3. That doesn't quite make sense because they're the same number. But then we also have that equal to line. So in this case, they are equal to instead of being less than. So we can still say true. And one way that we can remember these symbols, the greater than and less than part of them, is to kind of think about our symbol here as kind of like a crocodile or a monster. Let's draw some teeth on it. This crocodile, or alligator or monster, whatever you want to call it, always wants to eat the biggest snack, okay? So maybe there's 3 cookies on this side. That alligator is facing these 3 cookies because they want the most. So maybe there's only 2 on this side. So we can say 3 is greater than 2 because that alligator is trying to eat the 3 instead of the 2. That makes sense, okay? When 2 numbers are equal, if there's 3 and 3, then it doesn't really matter where that alligator is pointing to, if you can already say that those 2 sides are equal, like question E here. 3 and 3 were already equal, so we didn't even need to check that alligator symbol. Awesome. Exercise 2 is a little bit of the same thing. But before we can say true or false, we have to do some substitution. So let's scroll down here. And they are telling us a value for x or n or t. They want us to substitute into the inequality and then say if it's true or false. So this says 5x plus 2. I'm going to replace that x with a 4. Now I have 5 times 4 plus 2. And I need to solve that side and then check if it is greater than 28. 5 times 4 gives me a 20, plus 2 gives me a 22. So now we have 22. This alligator is pointing to the 22, so it's kind of saying 22 is greater. But we know that is false because 28 is actually greater. So I'm going to put an F for false. Same thing with question B here. I want to replace that n with the 12 because they tell me that n is equal to 12. So we're going to do some substitution. This time I have 2/3, which is our fraction here that's being multiplied by 12, minus 1. And they're telling me that it is less than 11 because we see that alligator symbol as trying to eat the 11, which means they're saying 11 is greater. But let's check if that's actually true. 2/3 times 12 should actually give me an 8. Minus 1 gives me a 7. So this is now saying 7 is less than 11. The alligator's eating the 11 instead. And we know that's true. 7 is less than 11. Very last question here, we have a -5. If I replace my -5 into that t space and substituting it in, we have -2 times -5 was actually equals a +10. But we still have to add that 6. So I'm going to add 6 here. That gives me a 16. So that whole 16, that's just from the left side. And then they had gave me a symbol to check and another 16. Okay. And like I said before, if you see that equal sign with 2 of the same number, we can automatically say it's true. We don't even have to check that alligator. Okay. We only have to check which direction it's facing if the numbers are different. So that's true there. And we are going to move on to exercise 3. Now that we know what these inequality symbols mean, we can actually use them, just like we did for equations, to solve for a missing variable. Okay? In exercise 2, they gave us the variables. We had to substitute and figure out if the answer was true or false. But in some different exercises, when we get down to exercise 4, we're going to figure out what number can actually work for each inequality. What number will make it true? If they don't give us that number, we have to find it. Before we do that, we have to make sure that the same rules that we use for equations will also work for inequalities. Remember how I said they're very, very similar? We're just going to test that out. They gave me the inequality 10 greater than 4. That's what they wrote in this question here. And they said they want us to do each of these things on both sides of the inequality. So just like we did with our equal sign, I'm actually going to draw a line down that inequality symbol. And for A, they want me to add 5 on both sides. If I add 5 on both sides, now we have a 15 is greater than, that alligator's trying to eat the 15, 9. And we can still say that that is T for true. But what happens if I subtract? Taking that same inequality from the question, now they want us to check subtraction. Will it work with these new symbols? Subtract 2 on both sides. 10 minus 2 gives me an 8. 4 minus 2 gives me a 2. Is 8 still greater than 2? Yes, it is. T for true. What about multiplication? You guys can probably try some of these on your own. If you wanted to pause here and do the work and then come back and check. Oops, I even wrote the wrong number there. Still using 10 and 4, the same inequality that we're starting with, just to check if these operations will work. Multiplying by 3, let's figure that one out. 10 times 3 is 30. 4 times 3 is 12. That still works. 30 is still greater than 12. T for true. What about dividing by 2? 10 divided by 2 is 5. 4 divided by 2 is 2. 5 is still greater than 2. That still works. T for true. So this is telling me that I can do exactly the same thing that I would with a regular equation to solve these inequalities. So like I said, when we move down to exercise 4, we're going to draw our line down the equal sign and pretend this is just a regular equation, try to solve to get that x by itself. We're doing the opposite, so I'm going to add 5 on both sides. Okay, we just proved that it would still leave it true, so we are allowed to do this. My 3x is left. My symbol is still the same, and 16 plus 5 is 21. Then we can divide by 3. Okay, again, they're very similar steps to solving equations. I would reduce that 3 to 1. Now the x is by itself. Symbol is still the same, and 21 divided by 3 is 7. So now I know that x has to be less than 7, right? This alligator symbol is pointing to the 7. That means the 7 is bigger. So x has to be less than 7. And what we like to do with inequalities is to draw that on a number line, okay? Because x doesn't have to be 7 exactly. It has to be less than. So it could be 6, it could be 5, 4, 3, 2, 1, 0, any negative numbers. And so what we can use to show that is a kind of number line here that will keep going in the correct direction. So I'm going to find the 7 space. So here's 5, 6, and 7. And what we want to do is draw a circle on that 7. Okay. We don't have the equal to line. So the answer can't actually be 7. It's not allowed to be equal to. So we leave that circle open. And then we need all of the numbers less than 7, so we can color this side of our number line. Okay, we need open circles unless you see that equal to line on your symbol. And then you have to look at which direction the alligator is pointing. 7 has to be greater than any value to make it true. So the values could be a -10, -5, 0, anything less than 7, like we said. Same thing over here. Let's solve this one. Draw my line down the symbol. I'm using my opposite operations to try and get that n variable by itself. Positive 22 minus 22 reduces to 0. I have a 5n left with that symbol here. And we have 10 on this side. Then I want to divide by 5 to get n by itself. So n has to be less than or equal to. Now we have that equal to line. And on our right side here, we have the number 2. So I'm using this number. on my lumber line, let's find that space. Here's 0, 1, and 2. We can label it. That's where I'm going to draw my circle. Okay, whatever the value is where you want to draw that circle. Then we only color it in if we see that equal to line. So this one actually will be a colored in circle. The n could be a 2, because then it would say 32 is equal to 32, and that works. Or the n could be anything less than 2. That alligator symbol is pointing to the 2, which means 2 has to be the biggest. N could be anything less than that. So again, we're going to color the less than side. It could be a -10, a -5, a 0, a 1, anything less than that value 2. All right. Hopefully all of this makes sense. I know it is new with these symbols, but they're the same rules that we're using to solve two-step equations, just using them for inequalities now. So I want you guys to take a look at your practice section. There are 4 more inequalities to try. Solve them exactly the same way that you would an equation, and then follow those steps for drawing the number lines, okay? Whatever value you get, you draw the circle. If you have an equal to line, you could color it in. If you don't have an equal to line, leave it open. And then you can kind of scribble on either side. Is it supposed to be less than or greater than? Then we have one last problem for our exit ticket, our self-reflection as usual. And then you can choose one activity from the choice board for today. That's it, guys.